12B, which is called Hurricane Helene. And so we're going to end off our session with a bang because Hurricane Helene was just an incredibly destructive storm that many of you probably know hit the southeast U.S. in September of 2024 and caused just devastating flooding in the Western Carolinas, and particularly North Carolina. And it led to a lot of loss of life and just tremendous destruction. And I have to tell you, I know this part of the world really, really well. I had family that lived in Western North Carolina for a number of years. Thankfully, I don't have any family left in that part of the world, and I didn't last year. But I know the areas that were affected, and I know the rivers that flooded. And so I probably spent way more time than usual trying to figure out what it was I was going to say in this video than I do for the other videos. And what I finally decided was I'm going to try to stick pretty much to what the AMS is discussing in the investigation, although I am going to add a little bit of stuff of my own. But this is the last video. This is the last investigation of the session. And I know that at the very end of these sessions that I'm pushing you really hard and you don't have a lot of time. So I don't want to actually make you kind of sit through a really long video when you've got a lot of work to do. I will say right off the bat that because this was such an historic storm, that if you are interested in Hurricane Helene, that obviously there's just an immense amount written on it on the internet. There are a tremendous number of pictures and videos. You can go to YouTube and see videos of what actually transpired in the Western Carolinas as a result of this particular storm and the rainfall that preceded it. So I'm going to try and keep this not brief, because none of my videos are brief, but I'm going to try and keep this within the normal 15 to 30 minutes that I allocate for a video. And again, I'm going to just leave it to y'all, if you're interested in more, to go and get some more of this information on your own, because again, it's readily available. So why don't we go to the PowerPoint and let's see what I ended up deciding to show you guys, and let's just get started. All right, so 12B, Hurricane Helene. So the setup for this storm is kind of unusual. We obviously get hurricanes that come in on the Gulf Coast and the Atlantic Coast with some regularity every year. In fact, as I make this video at the very end of September of 2025, it's been remarkably quiet here in the U.S. The hurricane season is not done yet, and we have a couple of storms kind of churning just to the east of Florida. But all things considered, we've had no landfalling major hurricanes this year. And so it's been a really quiet year in the U.S., unusually quiet. And I don't think anybody's really sorry about that, particularly after what happened in 2024. We had a couple of big hurricanes that caused damage in Florida, and then again, obviously, up the Appalachians into the Carolinas. And the setup for Hurricane Helene was that there was a stationary front that was basically just draped along the Appalachians, all the way going into the Gulf of Mexico, all the way up through the spine of the Appalachians into the Northeast. And we had subtropical high pressure. This is the Bermuda High, located over the Atlantic. And then we had basically a cutoff low to the west of the Appalachians. And what happened was the stationary front basically just got caught up between these two systems. And as the Bermuda High, with its clockwise circulation, funneled warm, humid air off the Atlantic Ocean, this warm air was basically forced to glide up and over the frontal slope, basically along and to the west of the stationary front. And as I'm going to show you in a few minutes, the actual positioning of the stationary front on surface maps, in my opinion, was not correct, and in a sense kind of explains why the Western Carolinas yet experienced so much flooding versus further west, where the stationary front was analyzed on a lot of National Weather Service maps. But anyway, just a tremendous amount of precipitation basically formed along and ahead of the stationary front, and then on top of this, a day or two later, after already a lot of heavy rain had fallen along the southern Appalachians, then Helene came in on the Big Bend of Florida and basically rode up along the front and then just pummeled the same areas of tremendously heavy rainfall. And of course, the result of this was just historic flooding and all of the loss of life and destruction that I mentioned a couple of minutes ago. So this is from the investigations manual, and this is, I believe, figure 12B1. So you can see the setup, and you can see a satellite map, and this is from September 26th. And basically, this Helene came in September 27th, and then September 27th was really the big day for the massive flooding in the Carolinas. So you can see with the stationary front basically draped all the way from the Gulf through the Northeast. You can see just this tremendous shield of cloudiness basically extending from Ohio, Kentucky, Tennessee, Alabama, all the way to the Atlantic Ocean. Here's Helene, just a couple of hours from coming in on the Big Bend of Florida. It did come in as a Category 4 hurricane, so it came in as a major hurricane. You can see the eye of the storm right here. So basically Helene is just part of this larger system that was associated with the stationary front. When you have a more classic situation of a hurricane, typically you'll see just a very, very clear hurricane all the way around and very clear skies all around the hurricane circulation. So again, this is very unusual to have this hurricane actually coming in and then riding up along a stationary front. Okay, now this is not from the investigation. I pulled this myself. This is from the Weather Prediction Center, and we're going to take a look at a couple of WPC maps in this particular video. This is from Thursday, September 26th, and this is the 12Z map. And you can see Helene churning in the Gulf. Here is the stationary front. And again, what I said earlier is that I believe the stationary front was analyzed on these maps just a little bit too far to the west. If you consider that when you get overrunning with cooler air basically to, in this case, it's not to the north of the front, this would be to the west of the stationary front, and the warm sector to the east of the stationary front, you would expect for the heaviest rain to set up here to the west of the stationary front in the cool air, where the warm air is forced to glide up and over the frontal slope. And that is not what happened. And so I actually believe that the front was actually a little bit, probably about 100 to 150 miles further off to the east and the southeast, basically where I have my cursor. So here's where I believe the stationary front was actually located, and we'll see why that's so in a few moments. Here's the hurricane that will eventually ride up and along the stationary front. Now, if we take a look at a different analysis from exactly the same time, here is Asheville. Right here in the square, you can see that the winds in Asheville are from the north, and you can see that it's raining heavily in Asheville. Now, the hurricane, again, is way off the bottom of my screen here over the Gulf, but we have just this very warm, humid air coming in, gliding in from the Atlantic, and you can see the dew points are way up in the 70s. So this air has a lot of water vapor in it. Now, if you take a look at Asheville and everything to the south and east, what you'll see is that somewhere between Asheville and Charlotte, which is right here where I have my cursor, this is where the front is actually located. And you can see that the winds shift basically to the north and the west of the front. They shift from the southeast to the north and the northeast. And so Asheville is actually on the cold side, relatively speaking, of the stationary front. Temperatures are in the 60s instead of the 70s, and the dew point is in the 60s instead of being well in the 70s as well. So it was happening in Asheville a good day, day and a half before the hurricane actually impacted it, was that the stationary front was draped basically off to the southeast of Asheville. You had this incredibly warm, humid air coming in from the Atlantic, and then it was forced up and over the stationary frontal slope over the cold air, and then it poured over Asheville. Now, in addition to the upward motion caused by the front itself, Asheville is in a very hilly region. So Charlotte is in the Piedmont. Asheville is in basically the foothills of the Appalachians. The spine of the Appalachians is really right along the North Carolina-Tennessee border. So basically you have upward motion due to the front, and you also have air being forced up by the foothills of the Appalachians. And the result was an extended period of heavy rain in Asheville that had nothing to do with Helene and everything to do with the stationary front. So a good 3 to 5 inches of rain had already fallen in Asheville before Helene even began to impact the weather over that particular area in the Western Carolinas. So the ground was soaked, it was saturated, the rivers were running high, and so when Helene came in the next day, there was really nowhere for that water to go. Now, the other thing that I want to just emphasize before I move on is that Asheville and the rivers that drain the Appalachians, Asheville is in a fairly mountainous area. It's in a valley, it's in a river valley, and the river that goes through Asheville is called the French Broad. And we're going to take a look at the French Broad in greater detail in a few minutes. So basically, Asheville, unfortunately, is positioned right in the floodplain of the French Broad. Downtown on both sides is in the floodplain of the French Broad. And then if you're in Asheville, if you've ever been to Asheville, you know that the hills and the mountains rise pretty quickly away from that floodplain. So when it rains very heavily, the water is just channeled down the French Broad. And that, in fact, is what happened with this heavy rain that preceded Helene. And in fact, as we'll see at the end of this presentation, before Helene even arrived, the French Broad through Asheville was already in minor flood stage. And so it was already flooding before the hurricane even arrived. So this is basically the setup going into Helene. Now, what I want to do next is actually talk about a lot more about some of the information that's provided in the investigation. And so what we're seeing here is a forecast map that was provided by the National Hurricane Center, and this is from Monday, September 23rd, 2024 at 11 a.m. Eastern Daylight Time. And so what the National Hurricane Center does is it begins to put out forecasts as soon as a tropical disturbance intensifies into a tropical depression. And so a tropical depression is basically any sort of a tropical system where the wind speeds begin to pick up, but they're still less than 39 miles per hour, which is the threshold for a tropical storm. So this is the first forecast that the National Hurricane Center put out. It's Advisory 1. Here's the location of the tropical depression. And by the way, we don't name storms until they actually become tropical storms. So 11 a.m. on Monday, this was just Tropical Depression 9, potential tropical cyclone 9. And so it wasn't Helene quite yet. And then what we see here is the forecast track for what would become Helene starting at 11 a.m. and basically following it all the way through 8 a.m. on Saturday. So just to talk a little bit about what we're seeing here. Inside the circle, you'll see that we have letters, and the letter depicts what the National Hurricane Center thinks this storm is going to be classified at each one of these times in the circles. You can see 8 a.m. Tuesday, 8 a.m. Wednesday, 8 p.m. Wednesday, 8 p.m. and so on. So basically go from tropical depression to tropical storm Helene. So it was basically forecast to become a tropical storm by the next day and then stay a tropical storm, basically move between the Yucatan and western Cuba as a hurricane, and then basically move through the Gulf as a hurricane, come in at the Big Bend of Florida, and then basically end up just a little to the west of the Georgia-South Carolina border at 8 a.m. Friday, and then kind of dissipate by the time we get to 8 a.m. on Saturday. Now, there's a lot of information that is pasted beneath this map. So Tropical Cyclone 9 gives you the time of the advisory. The current information is basically given to you by the X, which is just our first circle. It gives you the actual location, lat long, of this tropical depression at 11 a.m. on, for our advisory 1. Maximum sustained winds are 30 miles an hour, so it's just a little bit below tropical storm strength. And then the movement of the center of this low is north at 6 miles per hour. Now, as you take a look at this map, you want to make sure to pay attention to the legend. So the potential track, we're going to talk about this in a moment, for the first 3 days of the forecast, is this area that is just shaded white. And then after we get through this, for days 4 and 5, because it's a 5-day forecast, they stipple this area in instead of shading it white. And we'll talk about why that is in a moment. In terms of the watches and warnings that the Hurricane Center puts out, for a hurricane watch, the color is salmon. For a tropical storm watch, it's yellow. For warnings, a hurricane warning is red, and a tropical storm warning is blue. Now, when we have a hurricane or a tropical storm, what the Hurricane Center will do is it will shade in the area around the storm where there are tropical storm force winds and hurricane force winds. And we'll see that as we move forward. Now, in terms of the actual shading, as we move forward in our forecast, you'll see that the actual storm track that's predicted by the Hurricane Center is right here through the middle of our shaded area, as well as, again, indicating whether we had a depression, a tropical storm, or a hurricane. Now, this is called the cone of uncertainty. So the cone of uncertainty is basically indicating where the actual storm center could be located at any one of these times. And not surprisingly, as we move forward through our forecast, the width of the cone increases. In better words, the forecast uncertainty increases. Now, the Hurricane Center will show the storm track, and at the same time, it will tell you, do not focus just on the storm track, because, in fact, the actual center of the circulation could be anywhere within the cone of the uncertainty. The problem is that when the media sees these maps and when the media sees these tracks, they emphasize the track, even if they're telling the public that if you're inside of this cone of uncertainty, if you're located inside the cone, you really need to pay attention. You really need to prepare for this storm. So the reason that we have this cone of uncertainty is because tropical systems are notoriously difficult to forecast. They're tropical. They do not have any cold air associated with them, and in fact, and it's kind of something that we talked just a little bit about in the investigation, but not much. And that is that, in fact, for these incredibly powerful storms to exist, they have to exist in a larger environment where winds are actually very, very weak. And so it's very difficult to forecast the precise position of these systems when you don't have an overlying circulation moving them around. Now, we typically have a subtropical high pressure system that's located in the Atlantic, and what will happen is very often these storms will be located on the periphery, on the western periphery of the high, and so the clockwise circulation will tend to steer these storms along clockwise as well. And you can kind of see in this forecast this kind of clockwise motion of the storm's prediction until it actually comes inland and then begins to curve off to the northwest. So this is basically the setup. And I want to say that this is a good 3-4 days out from when the hurricane actually makes landfall. And I want to say that of the maps I'm about to show, this is actually the best forecast. This forecast 4 days out was incredibly accurate. The Hurricane Center did a great job with this forecast. You'll see as we take a look at forecasts as we get closer to the actual landfall that in fact the forecasts relative to what actually verifies are not quite as good. And that again lends credence to the fact that the positioning and the forecasting of the movement of these storms is very, very difficult. Now, just before I move on, I will say something about these stippled areas for days 4 and 5, and that is basically that the Hurricane Center stiples these in basically because the cone of uncertainty really gets very, very wide on days 4 and 5. So you can see, for example, that on day 4 going into day 5, the position of this hurricane or tropical storm could have been anywhere from the northeast corner of Arkansas all the way into central North Carolina. So you're really talking about tremendous uncertainty by the time we get into days 4 and 5 of a prediction of a tropical system. Okay, here's Wednesday, September 25th. This is advisory 9, so we're a couple of days further into this now. And Hurricane Helene is now formed. So the storm has formed, it's now a hurricane, and you can see that relative to the prediction from the previous screen, its position is just a little bit to the west of where it was forecast to be on Monday. Again, we're at Wednesday now. You can see we have a hurricane. You can see we have a couple of hurricane warnings along the eastern tip of the Yucatan, and we still have tropical storm warnings over western Cuba and a little bit further in on the northern side of the Yucatan. And if we look at further north, now you can see we have hurricane warnings along the Big Bend of Florida, where the hurricane conditions are ultimately expected to occur, and then tropical storm warnings basically on the periphery going all the way up the east coast of Florida, along the east coast of Georgia, South Carolina, and then we have a tropical storm watch just on the northern part where Myrtle Beach is, the northernmost part of the coast of South Carolina. If we take a look at the forecast positioning, we now have a hurricane. By the way, the sustained winds at this point were 80 miles per hour, so Helene was just a minimal hurricane. 74 miles per hour is the threshold as we move from a tropical storm to a hurricane. So Helene was just becoming and forming into a hurricane as of 10 a.m. on Wednesday. And so the forecast path of Helene through the Gulf of Mexico, you can see basically, look at my cursor here again, basically moving through the eastern Gulf, forecast to become a major hurricane, in better words, a Category 3 or stronger hurricane by 7 a.m. on Thursday, moving very, very quickly northward through the Gulf now, forecast to make landfall right around 7 p.m. Thursday evening, and then move through West Georgia, and then just be positioned, basically in West Georgia, and then move through Tennessee, the central part of Tennessee, and then dissipate basically along the Tennessee-Kentucky border. So this is basically the forecast. Here is the area of tropical storm winds at this particular advisory time. So again, September 25th at 10 a.m. If you look really, really carefully in the X, you'll just see a little bit of dark brown here. So in fact, the hurricane force winds are just over a very, very small area. even though Helene had become a hurricane at this point. So let's keep moving forward. And here's Helene right at landfall, and it made landfall again in the Big Bend right at about 11 p.m. on Thursday. Just a little bit of detail about Helene, and you can just see, I want to just point out that the ring of tropical storm force winds extending out from the center of Helene is really quite large. Hurricanes are much, much smaller in size than mid-latitude cyclones. Extratropical is what I'm trying to say here, cyclones. So when you see basically a ring of tropical storm force winds this large, this is very, very large for a hurricane. And then if you go in towards the center of the hurricane itself, you'll see this much, much smaller area of hurricane force winds. Again, centered pretty much right over where the low is, where the center of the hurricane is. Typically, what you'll see is that relative to the movement of the low, the hurricane force winds and the tropical storm force winds extend much further out on the right side of the track, and that is actually the case here versus the left side of the track. We don't actually cover that a whole lot in this investigation. We focus on other things this time around, but just know that in practice, when you take a look at the track of a hurricane or a tropical system, the strongest winds will extend further out and will be stronger in terms of magnitude to the right of the track versus the left of the track. Just taking a look at a couple more details here. So here is the center of the hurricane at this particular time, 29.9 north, 83.9 west. Maximum sustained winds at landfall, 140 miles per hour. So this is a strong Category 4 hurricane, very, very destructive. The movement, north-northeast at 24 miles per hour. This is pretty fast for a hurricane. So it came in really fast, again, on the Big Bend. And so the rest of it is just taking a look at the key on the bottom of the particular map. All right. Let's talk about where Helene ended up on Friday morning. This is the surface analysis, again, going back to a Weather Prediction Center map. And here's Helene. By the way, Helene had already weakened to a tropical storm. These storms weaken very, very quickly once they make landfall. Once they lose their source of warm, humid air from the Gulf or the Atlantic, because these storms are driven by latent heat release as vapor condenses, these storms weaken very, very quickly. So just remember, here's Asheville in southwest North Carolina. Here's Helene. Again, the Monday forecast, our Advisory 1 forecast, actually really pegged the position of Helene on Friday the best of all the forecasts that I showed you. So here's Helene. And by the way, Asheville right here is on the cool side of this front. And you can see the pressure gradient force is huge here. So the winds are very, very strong. Wind is being forced up and over the frontal slope of Helene and then also up and over the foothills. So at this point, it's raining incredibly heavily over western North Carolina. Just to say a couple of other things, one or two other things about Helene at this point, and that is that when these storms make landfall and they are purely tropical, there are no fronts. A tropical storm, by definition, has no cold sector. It is a tropical system. It is surrounded by tropical air on all sides. Now, as these tropical cyclones begin to work their way further north into the mid-latitudes, they will typically begin to ingest cooler air into the circulation, and they will become either hybrid or what meteorologists refer to as going extratropical. So this storm was basically a hybrid tropical, extratropical cyclone at this point, and it was in the process of becoming more extratropical. And once it begins to integrate some cooler air into its circulation, you'll see that fronts begin to be analyzed on the low itself. Here is the old stationary front that's been lingering over the Appalachians the entire time, the entire week actually. And again, you can see, I believe, still basically located too far to the west as Helene is moving up along the stationary frontal slope. So again, Asheville located to the north of this warm front, and I still think to the west of the stationary front as well. I suspect the stationary front is basically extending where my cursor is. And all of this, again, just leading to tremendously heavy rainfall over southwest North Carolina. Here is the ultimate total rainfall map for the area that was affected by Helene in the Carolinas, actually extending through Georgia, Tennessee, and out to the Atlantic Ocean. I want to just say before we actually focus on the Carolinas that if you take a look at the legend, Atlanta actually got more than 15 inches of rain. And if there hadn't been massive flooding in the Carolinas, I think that the big story would have been flooding in the Atlanta area. Atlanta floods. All you need to do is snap your fingers on a day when it's raining, and you'll get flooding in Atlanta. Atlanta floods very, very easily. And so, in fact, there was tremendous flooding in the Atlanta metro area as a result of Helene. But again, we didn't hear much about Atlanta because if you actually move further north, again, into the foothills and the mountains of North Carolina, and you look really carefully, you'll see, and again, you might want to make this full screen. If just look to the east of Asheville and the foothills, you'll see some purple in here, some light purple. And these are areas that actually got more than 30 inches of rain. Asheville got between 15 and 20. So again, you're taking a look at amounts that maybe were on almost the magnitude of what was seen in Atlanta, but because of the very hilly and steep nature of the Western Carolinas, as well as the fact that downtown Asheville was in a floodplain, the flooding in the Western Carolinas was just far more devastating than what was seen further south in Georgia. So here's rainfall accumulation again from the 25th to the 28th of September of 2024, and you can see that this axis of incredibly heavy rainfall just works all the way along the foothills of the Appalachians in western North Carolina. Okay, this is a picture of downtown Asheville, and of course this is meant to make Asheville look really, really pretty. I found it online. I just kind of went to Wikipedia, I think, and grabbed it. But this is downtown Asheville. I've been here many, many times. For those of you who read my bio at the beginning of the session, you know I got my PhD in North Carolina at UNC. And again, I had family down here at the time, so I drove out to the mountains quite a bit. Here's the French Broad, going right through, cutting right through the middle of downtown Asheville. And on a typical day like today in September of 2025, when it's nice and dry, the French Broad is only a couple of feet deep. It's a fairly shallow river. You can see it moves along because, again, it's fairly hilly here, so it's channeled. And so this is basically one of the rivers, one of several rivers that just went out of its banks and caused tremendous destruction as a result of the rainfall preceding Helene and then Helene itself. Now, the last slide, and this again is from the investigation, this basically shows you the gauge from Asheville, the gauge height, just indicating the depth of the French Broad preceding all this rainfall and then following it. So here's September 26th, just before it began to rain, and you'll see that at Asheville, the French Broad is what, maybe 2-3 feet deep, and that's it. And then here's the rainfall that preceded the hurricane. And so this is the result of the rainfall that occurred as a result of overrunning at Asheville just to the west and north of that stationary front. And that rainfall, which was pretty heavy, brought the river into minor flood stage. And so you can see it made it up to about 10.3 feet just before Helene came in. So here is basically the end of the heavy rainfall event that preceded Helene. You can see the French Broad just dips a slight amount. And then here is what happens when Helene comes through with all of its heavy rainfall. And you can see as we move through Thursday, September 27th, I think this is the Thursday, and Friday, you can see that basically the French Broad goes up to 24.67 feet, and this is the highest that has ever been measured in Asheville on the French Broad. Now, if you go back, at some point after you're done watching this video, you could just stop it and go back, a minute or two in the video, and you take a look at downtown, you can see that downtown is only a couple of feet above that floodplain. And so basically the French Broad just swamped all of downtown Asheville. And a lot of the buildings that were closest to the river, the water actually came up to the top of the first story, as well as roaring through it. So it flooded a number of buildings. It took a number of buildings completely out. Never underestimate the power of flowing water. And you can see that the French Broad responded very, very quickly. It's a small river. Small rivers tend to respond very rapidly to heavy rainfall. And so you can see that over just a period of maybe 6 to 12 hours, the French Broad went from about 10 feet all the way up to this 24.67 feet. And so then the hurricane passed through, the rain ended, and you can see that basically from early on the 28th, and it took about 2 to 2.5 days, the French Broad slowly came down and went from its record crest into major flood, moderate flood, minor flood, and then basically just about October 1st, the morning of October 1st, it finally went below flood stage. And of course, what was left in its wake was a lot of loss of life and just immense, kind of unimaginable damage in Asheville. And Asheville is kind of just the biggest example in terms of size of a metropolitan area of the damage. But for those of you who paid attention to this, for those of you who know people in the Western Carolinas, you know that up and down the spine of the Appalachians, towns were just wiped out from this thing. Unfortunately, a lot of very small towns and villages in Western North Carolina are actually on the floodplains of these rivers that wind through the Western Carolinas. And so just tremendous damage. So I've probably talked way more than I need to versus what the AMS put in the investigation. So this is pretty much the end of it. So I'm going to end this video in just a moment. That's it, that's all. But I want to say that's it, that's all for our entire session. This is the last investigation video that I'm going to be recording for our class. And I just want to say on a note here, because I think that this is going to be the last set of investigations I'm just going to record from the AMS. I'm actually getting near the end of my career. I'm recording these videos in fall of 2025, and I'm going to use this set of videos right through the last time that I teach this class through early fall of 2026. And when I finish teaching this class during the early fall session of 2026, I'm going to be retiring. So this is actually it for me. So it's kind of personal for me. I've been teaching this class and teaching these investigations since fall of 2001. So I hope you've enjoyed this. I've enjoyed teaching this class. I've enjoyed doing this particular part of online teaching as part of my larger career. So I hope you've enjoyed this. If you have any comments, by all means, feel free to share them with me. But as always, if you have any questions about anything that I posted in this particular video about Helene, feel free to post to the discussion board or ask me live in my office hours in Zoom. But that's it, and I hope you've enjoyed these. I hope you've enjoyed our class. I'm going to end this now, and I'll post this on YouTube, and you'll see an announcement when it's ready for you to view.